Hey everyone, so in this video we're going to be going over the kinetic molecular theory of gases. So there are 5 assumptions with the kinetic molecular theory that we must remember. So firstly, gases are made of tiny particles in constant random motion. The second one is the volume of gas particles are negligible compared to the volume of the container. Thirdly, gas particles don't attract or repel each other. Fourthly, the collisions are perfectly elastic, so no loss of kinetic energy. And then lastly, the average kinetic energy of particles is directly proportional to temperature. So as temperature goes up, the particles increase in their motion, and as temperature goes down, they decrease in motion. And we can see the equation here, Ke is equal to 3 over 2 kT, where Ke is equal to the average kinetic energy, K, so this K, is equal to the Boltzmann's constant, and then the T is equal to temperature in Kelvin. So with that in mind, let's go over our first problem. If the temperature of a gas doubles from 150 Kelvin to 300 Kelvin, what happens to the average kinetic energy? So knowing the kinetic molecular theory, the average kinetic energy would double. Since it is directly proportional to the temperature, so it's going to double. Let's go to the next problem now. Which gas at the same temperature, helium or CO2, has faster moving particles? So the answer for this is going to be that since all gases have the same kinetic energy at the same temperature, lighter gases are going to move faster. So helium is much lighter than CO2, so it's going to move much faster. Helium, since it is lighter. And at the same temperature, they have the same kinetic energy. And let's go over one last problem. A 2-liter sample of gas at 300 Kelvin exerts 1.5 atmospheres of pressure. If temperature increases to 600 Kelvin and the volume stays the same, what's the new pressure? So for this equation, for this problem, we can use the equation P1 over T1 is equal to P2 over T2, which we've used in a previous video. And then we can isolate for P2. So P2 is going to be equal to 1.5 times 600 over 300, which is going to give us a final pressure of 3.0 atmospheres.